Hello everyone, welcome to 14th session of Artificial Intelligence. Today's session, Harun is going to lead. He will be wrapping up whatever the topics that is left in the Hive and might introduce the Spark streaming, where the data can flow in real time. After the break, he might give me 30 minutes, 40 minutes. I will give some addition, classification of what we done yesterday. So we have friends joining, Hari from India, Harish from California, Harun is going to lead, and Kishore from India, Leela from Minneapolis, I believe, I always forget, Narendra from India, Raja, don't know the city, Nagesh from STP. So yesterday, Hema, I believe, has done very good collaboration. She guided you guys. So moving forward, from this week onwards, I encourage you to involve in the collaboration. It's really, really very important you involve in the discussions, participation, and ready to take up a topic and present it. So Sairam, welcome. So that would give a lot of insight into the topic. So you don't have to be perfect. Perfection is enemy of the progress. So don't aim for the perfection. Perfection is needed, but it comes out of repetition, out of iterations, and out of perseverance. So in US or in any other country, changing IT career is very difficult. So I've seen many people want to change from one skill to another. So 90% of people who aim to change their career, they cannot change because change is so difficult, especially acquiring a new skill. But interestingly, that is my area of focus and interest, to help people to make the transition or change possible. So that was my interest last 10 years, 20, 15 years. So I've been working on it. So today we are interacting. Definitely we are discussing a lot of knowledge. But I think you might have observed, we include a lot of team dynamics, psychological aspects, which motivate us to focus and learn continuously and move forward. Not only that, we discuss things very iteratively. I don't know if you have observed the patterns. Our mind is so powerful. You see a lot of iterations, repetition. You see we are following a continuous process of collecting the data, cleaning the data, preparing the features, and giving it to model, testing it, fine-tuning the hyperparameters. During the process, you've been writing functions. You've been start using the API, getting used to write some Scala code and passing through different algorithms and seeing certain connections, understanding mathematics, all these things, you see that it is getting consolidated. And then on top of it, we started involving the team to lead the discussions. So we have examples. When Harun was from second batch, Nagesh was from third batch. They involved extensively to discuss big data engineering. Now they have even greater role to play. And I've been, you're watching, you're observing. We are involving every one of you. We started with Hema because she interacted with Harun and me and showing a lot of interest and want to share her knowledge. So we initiated. So, but she did a great job. Yesterday I've seen the recording. It was so nice, and you guys all started taking the code and running it. You see, you don't need a lot of strength, a lot of knowledge to do this. It's just a matter of perseverance, steadily doing it, not alone, as a team. It's always, remember, stay with the team, connect with the team, communicate with the team, try to understand how they see the subject. There is no subject that is difficult. It is just a matter how you see it. Harish will see one subject differently than me. So if I talk to him, he can make things easy for me. Harun might take up a topic and dig into it and can see differently. Big data engineering, Hive. He can guide us to inspire and to see the things easy. In the way like Kiran, Kishore, Leela, you guys can take up small topics, dig into it. You can see different dimensions of the subject. Then can connect with people. It's a lot of fun. Then things will become easier. So collaboration is the key. If you surround yourself with right people, and things will become difficult. Things becomes easier. So it is not a theory. I'm pretty sure you've been observing it. So that is where I strongly encourage everyone of you. So Nagesh, Leela, Siva, welcome. Sairam, Raja, Narayan Rao, Leela, Hema, Harun, Harish and Hari. Okay, let's continue. I will next week also. I'll after the discussion I will share. Next week also, the Hema team will continue. There is a multi-classification instead of 1 and 0. How you classify into multiple classifications? If you have text, if you have images, even how you classify reading images, like one, if you handwritten digits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You write checks. You write a check and put in the bank. The bank ATM can recognize your handwritten. So there, the images are classified into either 1 or 2 or 3, 4. Actually, these type of problems are mainly solved with neural networks in deep learning. But interestingly, some people use even decision tree, but we can show you how demonstrating decision tree even to solve it. So I'll work with Hema team. This time Hema will involve a team also. So that would give you 1 week time. Then Monday or Tuesday, I'll give the focus topics for all other teams also, so that we'll plan for not only coming week, next week. So every week, one team will be rather leading the sessions for 30 to 40 minutes. How does it sound, Nagesh, Narayan Rao, Sairam? How does it sound? Leela, Hari, Harish. Okay, excellent. So without taking much time, I am going to...
Srini, one second.
Yeah.
Yesterday, somebody has an issue like the version of the Spark was older than 2.3.0. So we can control this while creating the cluster.
Yeah, I already seen that, Hema.
Okay.
I just detached my cluster and I added a new cluster, and there it says clearly.
Okay.
Thank you.
Okay, awesome. I've seen that, yeah. So they have upgraded the cluster from 2.2 to 2.3. Interestingly, they gave the two clusters to you. Okay, wonderful. So Harun, I'm going to pass it to you, the control. You can take it forward. Sairam, how does this sound? Are you ready for greater collaboration?
Yes, I am. Let's do that.
Excellent. Does it sound interesting to you?
Absolutely. Yeah.
Excellent, guys. So we have excellent team, guys. So let's take each of us a role, and we can make it more interesting. I can continuously talk, I can continuously give the session. You like it, but what happens after some time, you still like it, but you'll not be learning much. You'll be more listening, but we need a more action from you. So as you're going to present, I encourage you to use a microphone instead of a computer speaker, because you may have a background noises, so your presentation may not be effective. A simple Apple, some $20, $30, or some other microphone, earplugs, it will avoid a lot of noise, and you feel very comfortable in making the presentations and discussions, and it will be very, very effective. I encourage you, please take care of that. So Harun, I think you have control now.
Yep, Srini, thank you.
You can take it.
I will start. Yeah.
Thank you. I'll catch up after 10 after the break.
Sure. Thanks. Okay. Good morning. Good evening, team. Welcome. Let's continue our big data engineering sessions. Today's agenda is we have something left from our last week Hive session. We just have one topic we wanted to cover. That is the bucketing concept of bucketing in Hive. And then we will move on to the streaming concept, Spark streaming. So from the Lambda architecture, we have been working on the Spark programs, running the Spark programs. So we will simultaneously start the Spark streaming concepts today. And going forward, we will take up different data sources that we can connect and talk to with both in both the modes, batch as well as streaming. So Spark streaming and Spark batch programs, we will try to, we will connect to various data sources like Kafka, Twitter, and of course the files to pick up the data, pull the data, and then we will also look at putting the data from Spark, the processed data, back into the data stores like Elasticsearch or Cassandra, this kind of data stores. Okay, so with that, let's get into the topic. I hope everybody can see my screen and hear me okay. Right?
Yes, sir.
Okay. Okay. Yeah, great. So what we discussed in the previous sessions in the Hive is we discussed creating tables, putting data, reading tables, everything, right? So, and then we also discussed about partitioning. Okay. So let us see what we said about partitioning. Partitioning is like segregating the data, storing the data separately based on the attributes we want to partition. Like we looked at the country, the HR data based on country and state, and then we had created partitions to store the data as per the partition. So we looked at each country had a separate directory, separate file, and within that each state had a different file. So as and when you get more records with a new state, it creates a new file, and you get more records for the same state, it puts into the same file or a new file within the same directory. So here the number of directories or files are not same, right? So as and when we get new states, new countries, we grow the data. Okay, but at least we know that the country and states are fairly static, because you don't create new countries or new states every day. I mean, you can get the data from a different country or a different state, but once we have all that set up, it's not very dynamic. It's fairly static data. But for example, if we say a employee ID, right? So employee ID or a date is fairly a dynamic data. So you can say, so every day or hour or minute, you get new directories. So it gets messed up. You get a lot of directories and files get created, right? So it's not always it's not always the solution to create to partition the data in Hive, but you can also do bucketing. Okay, so bucketing is also distribution of the data, indexing and distribution of the data within Hive, but it works on a algorithm, some hashing logic. It uses a hashing logic. Whereas in partition, there is no logic. As long as, it's just straight read and put. You get a new record, put it in directory, you get a new record, check whether directory is there, not there, create a new directory and put it, that's it. So that's the whole logic it has. But in bucketing, what it does is it does a hashing logic and creates a unique key. It's not for us, but internally it generates the hash key and distributes the data as per the hash key. So what that means is the number of directories is or the files is fixed. When you create a table, you define how many buckets you want. Okay, so it's like segregating the data into buckets. So I have 10 buckets. Okay, I bought 10 buckets and put it. So whatever the data I get it, I can only put in one of these 10 buckets. Okay, it doesn't matter how much data I get, but I have only 10 buckets. I cannot create a new bucket, so I have to distribute the data into these buckets. Now it's not equally distributed. Okay, the logic does not tell you that, okay, if I get 100 records, put 10 records in each bucket. That's not the purpose. The purpose here is to distribute the data according to the hash logic. Okay, so why that is, we will explore that. But for now, so that's the logic. Now, if I have 10 buckets and if I have 100 records, right? So if I put 100 records, the data may be skewed as per the buckets, which means that the first bucket can have 10, second bucket can have 50, third bucket can have 5, fourth bucket can have 0, so on and so forth. Okay, so it's not that you don't get equal. So hashing is generated, then you can define on what attributes you want that logic to be built, that hashing to be built. For example, the employee ID. So if you have an employee ID, if you want to define employee ID as the hash, as the clustering attribute, so it distributes the records based on the hash key it's generated generates using the employee ID. Okay. Now, if we use the same, so why do we use it, right? So once we distribute, like last time we discussed that when you join the tables, it will be easier to join because, as I said, like, so if I have say 5 buckets and if I have 100 employees, so first bucket has some 20, second 5, second 10, right? So five buckets. Now, if I have another table which stores the address, but again clustering based on the employee ID, because we have to join by employee ID, right? Name and address. So it will make sure that all the employees with the hash keys are in the same bucket, similar. So when it joins, when you join the 2 tables, it will only take those buckets and join against each other. So bucket 1 from here to bucket 1 from here, because it knows the similar employee IDs will be in the same buckets. So it need not join all 10 buckets from this into 10 buckets from the address. It's not 10 by 10. So it's 1 by 1. So the amount of processing that it needs to do when you join is very less because of the bucketing concept. Okay. So that's where it helps when you have millions of records, right? It's not millions of records if you want to join. So if you have 1,000 buckets, and if I say I want to join, say one employee record with one address and get the address by joining the employee and ID, I give the employee ID. So you need not join all the 1,000 buckets in both the tables. It can only pick one bucket where this employee ID will be based on the hashing key, and pick those 2 buckets and join those 2. Okay, did you get the concept? We will see how to create those buckets apart from partitioning. Okay. Any questions? You guys got the concept of bucketing in Hive, partitioning and bucketing?
Yeah, Harun. Only thing, at some point in time, if we need, it's not possible to create extra buckets.
I think you can modify. Yeah, you can alter and create, modify, but it needs to redistribute the data. Okay. Yeah. Okay, so let's see. So last week we had created tables, right? So I have these EMP parts, staging, partitioning table, and this is the staging table. And staging table, I have all the data. So I have data from 4 countries, right? So if I see here, let's go. In the partitioning, if I see, I have 4 countries and each country has multiple states and data in all of that, right? Now, if I go to EMP staging, okay, it's just files. Okay, all the files I have loaded. So I have all the data, 2,000 records in the table. Now I want to create a new table with bucketing, not partitioning, with bucketing. Okay, so I will define a new table. A new table, EMP buckets. Okay, and then I will cluster based on the country. Okay, and then let's say I create 10 buckets. Okay, so I will go here, EMP buckets, just change this to 10. So the syntax is this. Okay, so create table, everything is same, clustered. So this is what you want to provide, on which table on which attribute you want to bucket. You can have multiple attributes. So clustered by country into how many buckets you want to. So as I want to distribute data into 10 buckets. Okay, so if I do this, So there are 10 buckets that are created for this table. Okay. Now the data will be distributed into 10 buckets. Now, so the table is created here. So it's the EMP buckets. There's no data here. Now what I will do, I'll put the data. So we have the data in the staging table, right? Insert, overwrite into which tables is a staging table. Insert, overwrite table EMP buckets, and then this the EMP staging. From EMP staging, I'm putting into insert, overwrite table EMP buckets. Okay, from EMP staging. See the number of reducers here, and you just observe that it's trying to put the data into 10 buckets distributing. It's not that you have to know this map reduce this job. It's not relevant, just to note.
So we have to set the reducers, is it?
No. I'm just showing you it is automatically deducting based on the tables. You don't have to check anything from this.
Okay.
You just insert the data. It's why is it taking so long? Okay, so let's just start here. Okay, so in the last time we did country and state. Okay, say for example, each country has 50 states, right? And we have data in all the states. So how many files do we get here? I have 4 countries, and each state has 50. Each country has 50 states. So each state 50. So total is 4 into 50, right? So there will be 200 files that will be created in the partitions. You understand? Like we did last time. Correct? Yes, I'm not able to hear you.
Yes, Arun. Yeah.
Yes,
Okay.
Arun. Yeah.
So we get 200 files, right? So I put the same data, but I put in 10 buckets here with the country. Okay. Here we have only, here it's the same thing, the same data. So what we are putting it here, same 4 countries and 50 states. So it's 2000 records, same data, but we created 10 buckets here. Okay. So if I create 10 buckets, how many files that we get, right? So if you go here, So this is where the data is stored, right? EMP buckets. So this is the table, and this is the data that is stored here. Okay. If you look at it here, how many files are there? From 0 to 9, total 10 files. Okay. Because we created 10 buckets. So observe this. Do we have data? No, we don't have data in everything. How many files have data? 1, 2, 3. Only 3 files have data, not 10. Okay. But still there are 10 files that are created because you've created as 10 buckets, right? So if you put more data, one of these files goes to one of these files. Okay. But even if you're clustered on country, we have 4 countries. See, it did not put in 4 files, each country in one file. It chose based on the hash key that some data will go into this, some data go into this, some data will go into this. Okay. But if you just look at it, 4 countries did not go to 4 files, right?
Correct. But that hashing also we can control. You said we can control, right, based on our.
So the hashing is based on the attributes that we provide for hashing. So here we are hashing based on the bucketing based on the country. So if you hash based on the state, okay, the data distribution might be different.
Correct.
Okay, but still you will get 10 files. Okay, so here what I get 10 files. So this is the difference between partitioning and bucketing. Now this can grow. Okay, suppose there is one extra state that is created, okay, in some country. Now if then for that country there will be another state that is created, so there will be 201, but this will still be 10 files. This is fixed. Okay, now let's say based on this, so what I want to do, let me drop this table again, drop and create again. Okay, drop table emp buckets. Okay, now I want to create it with 5 buckets. Okay, I created with 5 buckets, and then I am putting that same data here. Okay, while that is putting the data, okay. Now, let's say I have an employee, okay, with country US and state California, okay, here. And the same employee, so I just have name there and address here. Okay. So I have clustered, say for example, I have not clustered, I've just partitioned here and put this here. So if I want to join these 2 tables, employee and address, with just partitioning, right? So it has to read, so if I don't have, just have the state, if I have just the country, then it has to read, even for one employee, it has to read all the records in the partition, right? all the records in the partition for the California. So it might have so 50 states, so it might have to read 50. If I don't have a state, it might have to read for country is US, right? So it might have to read 50 files here. Let's just take the country level. Okay, I have partitioned here, but I am searching for a US employee and joining to get its address. So it has to read 50 files here to read and 50 files here, and then join these two again to get the join for that employee. Okay, the same thing here if I do in bucketing. Okay, so this has 10 and this has 10. Okay, but it knows based on the country which bucket it goes to, right? It hashing. So it will pick one bucket here, and based on the hash, it will also pick one bucket here. Now it will join these two. Okay, so in this bucket, whatever records, and in this bucket, whatever records, and then it will join. See, the number of data that it needs to join, the Cartesian product it needs to do is reduced. You can see that instead of 50 here and 50 here to scan to get that employee, right?
Yeah, I think
Yes, sir.
Okay,
But
so
to me, if you are doing the bucketing by country again here, will it make a difference, Arun?
what is that? If you get country,
If you're doing the bucketing for a country, will it make a difference here is what I'm asking. Even though your buckets are only 10, if you're doing the bucketing by country, that is, I mean, you're hashing by country, right?
yeah.
So if it's all going to be US as a country, so will that make a difference for the read is what I want.
No, it is not US. We have 4 countries here.
Okay.
Okay, so what I'm saying is when you search for US.
Okay. Then this time. Correct.
When you search for US,
Got it.
it has to read 50 states here, 50 state files here, and then figure out in which file the record exists, take that and join that. But
Yeah.
it did not read all those. Even 10 it did not read. It needs to read only one file. Yeah.
Only one, in fact. Yeah.
Yeah. So that's the difference. Now, so if you see here, see now I get only 5 files. Okay. And only 3 of them have data.
Right.
Okay, and so this is the concept of how the bucketing works. But at the same time, you could as well use both partitioning and bucketing together. Okay, so for example, you can choose to what is that?
But you had mentioned like cluster. In that cluster, you said so many buckets, right? So how do you do for both?
I didn't get your question.
No. You said when you created, you said 10 buckets. So
yeah.
So how do you create like using both partitioning and bucketing?
Okay, so both in when you do both, right? What happens is the partitioning is at the higher level. Okay. Bucketing is at the lower level.
Okay.
So you can choose to partition based on country and then bucket based on the state. Okay. So I get 4 directories for each country.
Right.
And within each country, I will not choose to have the files or directories as many number of states. Okay. I just want to choose every country to have only 5 files for its data. So even if US has 50 states, that will be internally distributed for the 5 files within US. Okay. So what happens in that case is, if you go here, partitioning, right? So this will still be there. You partition by country.
Correct.
Okay. And within the country, if you go here, then you will not see all of this. You will see only the number of buckets you want. So if you say 5, you will have only 5 files here.
For each country, 5
Yeah, files, yes. So the number, it will come here, maybe say you want to have 5 buckets for each country. So then it will be 20 files finally. Or if you choose to want only 2 buckets for each country, then it will be 8 files. Okay. So, and then you can do some sampling and all that. But let's try create a partitioning and bucketing together, okay, and see what happens.
Okay.
Harun, I have one more doubt. Like you did the dropping of table, right? Is like, can we delete the 5 buckets alone, or we have to drop every time and create the buckets?
You can do, there will be lot table. So I just did it because it is easier.
Okay.
But you will have the DDLs and DMLs in Hive.
Okay.
You can alter the table. So you can go to see Hive QL. You will have all the, it's just like SQL. So you'll have all those commands to do DDL and DML. You do just like that, same in the Hive.
Okay.
So here what I'm doing here, I am partitioning by country. Okay.
Yeah.
And then cluster state into 5 buckets. Okay.
Yeah.
Now I will write the same staging data into this. Okay. So here when I write the syntax, insert overwrite partition country, you have to mention what is the partition, and you have to always select the last field that you are partitioning with. Buckets, you don't have to do anything. It is already there in the table definition. It will cluster into that.
Okay.
Static partition column. Okay. Then set Hive exec dynamic partition mode equal to non-struct. So there is no difference in accessing the data or storing, or any SQLs you write for any of these tables. All this will only define how the data is stored in Hive, how it is stored in different files, different directories internally within the tables for the Hive in the HDFS. So how many files would be created now? 5?
20. 4 5 20.
Yeah. We have 4 country, so we will have 4 partitions, and then buckets in that. You can see here. See, there is a how it's creating the partitions here. So first it is loading partitions, 4 partitions, because we had 4 countries. Then the buckets, for each country it is creating the buckets. See, num files is 5, because each country we are doing 5 buckets, right? So 20, this is the total number of records within this partition. So we know each country we were loading 500 rows. Okay. Then how is it distributed? Then you have to come and see here the size, the data, and the clusters. buckets, sorry, partition buckets. See here, so the first level here we have partitions. Now within each partition, so here we have only 5 files. Okay. Now if we go and check, so you can see the file size here itself. 15 KB, 15 KB, 30 KB, 815 bytes, 2 KB, right? So the records are not equally distributed even within the country US. Some states, so we have almost 50 states. Now it's distributed into 5 files, but the data in each file is different, not equal. Okay. So similarly, based on this, Canada, you have 5. So all countries will have 5 files. But here, see, in this file, there is no data, 0 bytes. Okay. In this, there is 28 KB. Here is only 5 KB. Here it is 8 KB. Okay. So the number of records will be different in each of these files. Got it? So any questions? We have set non-strict because when we are loading the data into both the partitions and the buckets, it wanted to have one static partition. So that's why we switched that property off. So we put non-strict mode here. Okay.
Harun, is there any performance difference between your bucketing and partitioning, or is just a more efficient way of storing the data on HDFS?
No. There is definitely a performance improvement. The whole purpose of it is to improve the performance. But you will only see the performance improvement when you have huge tables and when you're joining the tables. So
yeah, correct. Yeah.
Help only if you are joining very big tables. If you have small tables and if you are only getting data from one table, you don't see much difference.
Okay.
But when you have huge tables and you are joining, that's where you will see huge difference mainly because of you do Hive QL, there is a map reduce job that triggers, right? And it's so many reducer tasks, so many reducers, so many stages to get the data, to put the data in the temporary storage, then to shuffle the data, join the data. So there are a huge number of operations that go through when you do a complex join between two tables having huge data. So to reduce some of that complexity, they introduced this concept of partitioning and then bucketing. So it's all like filtering the data even before you try to join, right?
Yeah, yeah. Thank you. Yeah.
Okay. So that's what it is, the concept. Okay.
Okay.
Okay. So I think with this we will conclude the main topics we have in Hive. So you can I would encourage you to go through the Hive tutorial, whatever Srini has shared. If not, we can share. So there is not much complexity or not much functionality when you do any of these tools. Okay, it's not a language and it's not a product in itself. Product, I mean, it's not a ERP kind of a product or a proprietary product which has a lot of functionality, right? So these are small tools that enable you to write and read the data. End of the day, it's just like in the SQL. Okay, so most of it will be similar to SQL. Now, what you can do going through is create more tables, create different types of fields, put the data, read the data. So it's almost like SQL, and then join the data kind of a thing. there are some concepts you have to be clear when you attempt any interview. So some of the main concepts is they would ask what is partitioning, what is bucketing, and when do you use it. So that's what we looked at. When do we use it? And then joins. So there are different kind of joins that Hive has. So I would ask you to read through those. There's a difference in normal RDBMS joins and Hive joins, a few of them. So I would recommend to go through, read, and then try creating and using those joins. Okay. So that's all it has to Hive. Other than that, it's just like the HDFS files and writing SQL to get data from the files using the HiveQL, creating Hive tables.
Okay. The one main question which I would assume what could probably come up is why use Hive instead of the other RDBMS or SQL or like those kind of database. So could you give some advantages of using Hive?
See, yeah, the whole purpose of Hive came up because of the huge volumes. Hive came up because of the HDFS. So to solve the issue of volumes, we moved from our traditional storage to Hadoop storage, HDFS. Okay. Now HDFS you cannot read from RDBMS, right? Again. Okay. So to read the data from files, HDFS files, Facebook has come up with a tool called Hive. So the purpose of Hive is different from the purpose of RDBMS. These are two different entities. I mean, you cannot compare these two, but RDBMS is and will be continued to be used in the schema of things where you have relational data. Okay. Correct. One is relational data. Two is transactional data, OLTP. Okay. Wherever there is transactional data, OLTP, transactional processing, you will continue to use RDBMS. It will continue to be there. Okay. Right. When you come on to the big data or the Hadoop, it's the idea of Hadoop is the data mostly to be immutable. There are no transactions. It's analytical data. It's OLAP tools. Okay. Right. Because you're doing analytics, you get huge data, but that is mostly to be immutable. Now, because of those huge volumes, you wanted to query the data. So since querying the data on huge files is difficult, now it came up with a tool called Hive to read the data from the Hadoop. Now, there are so many other tools like Impala, like HBase, which will allow you to read and write data on Hadoop into and out of Hadoop.
Okay. Okay. Which are also some kind of tools which can help us, say for example, we may have all this data like in SQL. So for example, if we want to move our the data that we want to analyze or the data what we want to move to Hadoop, there are some tools like that which can help us move the data.
Yes, definitely. So one of the tool is called Scoop. Okay. It is a SQL on Hadoop. So what Scoop does is lift and shift the data from your RDBMS onto Hadoop.
Okay.
Or from Hadoop to your RDBMS.
Okay.
Okay. Wonderful. So how it works, again, it works on the MapReduce, just like this. It will start running the jobs and creating maps and reducers and all that. So it's a tool. I mean, we can explore that also towards in the advanced topics towards that. It's a small tool, very small tool. It doesn't have any much functionality. Its only functionality is to pull the data.
Yeah.
From RDBMS to Hadoop and Hadoop to RDBMS.
Yeah, okay.
Now, so it has the connectors to connect to RDBMS, and then you can write on Hadoop directly to files, or you can choose directly to write to Hive tables, just like we have here, right? Hive. So if you have Hive tables, it can automatically write that data to Hive tables, which means that it will move the files to that location where you are referring to your Hive tables.
Understood.
So you can automate the job to run sequentially. Okay. I mean, iteratively, delta processing. So every day, whatever data you get in RDBMS, transactional data, you can pull that and put it on Hadoop on a daily basis. So it has some functionality to incrementally write the data.
Okay. Wonderful. Wonderful. Yeah. Great.
Apart from that tool, you can also write directly from Spark. Right? Spark, we have seen that it can connect various data sources. So one of the data sources you can also connect to RDBMS using your JDBC. Okay, in fact, I connect from my Spark, I connect to both MySQL, I connect to Mongo, and I connect to Teradata. Okay, so it has connectors. All you need is you need some jar files that are the supporting jar files to connect, and then a driver, so you can directly connect to that RDBMS and pull the data. And once you pull the data, you can choose, once it is in the Spark, you can choose to write to Hadoop or write to any database or whatever you want to do with it. So there are two ways of doing it. Either you do from Scoop tool or you use Spark, and there are different ways, but I mean, in the end, so if you use Spark, it uses the JDBC connector, but it will be faster because the underlying, it will be the Spark engine. Scoop runs on the MapReduce engine. But however, Spark is not designed to do those kind of ETL jobs. I mean, the purpose is different, but you can still use it. Got it?
Thanks, sir.
Yeah. Okay. So, guys, any other questions? Okay. So let's stop it there. Let's take a minute, and then we will switch the context from Hive to our next topic, which is the Spark streaming. Okay. All right. Let's go here. Let me share my. Okay. So I guess you all remember this. Just give me a minute. We'll start. Okay, guys, welcome back. So you all had seen this Lambda architecture, maybe modified. This is very old. I couldn't find the latest on this, but the purpose is this. So here we have, in the Lambda architecture, we have two prongs. One is the batch here, right? So that is what we have been doing using Spark programs, the batch programs. Now the other layer is called a speed layer, which is the streaming layer. also called streaming layer, where we process the data, which is streaming, which means the live data. So why we need two? Because the streaming layer, you might keep getting continuous data, for example, the network data or the credit card transaction data, right? So you have various scenarios where you want to do processing while the data is in motion. Okay. If you have a credit card transaction that is coming in, right, you cannot wait to store that the transaction and then process it later and find out, say after 1 hour in a bad job, that it is a bad transaction or it is a fraud transaction, right? So you need to have something where you can immediately, while the transaction is processing, identify it as a fraud and block it before the transaction happens. Correct? You guys agree with me?
Correct.
Yeah. So what we are doing, we are trying to do the machine learning, right? So we are trying to do a machine learning. We need to train the machine to identify what kind of transactions would be fraud, right? So we are training the machines, we are training the algorithms with the data we have. We are testing it, and once we have our model ready, what we will do with the model, it's not, the purpose is not to continuously do just the training and testing, right? The purpose is to deploy it in the live model. So once we do training and testing in production, it has to predict the live data, whatever the transaction that is coming in. It has to predict based on the training we have given, the testing we have done. The model has to predict whether the transaction that is coming in is fraud or not. Okay, let's say it's a classification problem. Okay, yes or no. Okay, whether it is a fraud or not fraud. So when the transaction is happening, the moment the transaction comes in, okay, we put it into the streaming, into the big data, into the Spark streaming, and then put it to the Spark ML model that we have already created, trained, and put this data into that model and come out with a decision based on the transaction data and based on the model to say whether it is a fraud or not. And based on that, we give the response. If it says it is fraud, then we immediately send the response back and block the transaction going through. Okay, and then sometimes you get the notification that we have blocked this card because of this transaction. If it is you who's doing a transaction, please send response or whatever, something like that, where you can remove that block. So what are the conditions? Say, for example, how did we train our model? We say, for example, the transaction data is coming in from multiple geos. Okay, the same card number is being used from the same multiple locations on the same time, at the same time. So that can be one. We have trained it to put it as for example fraud. Or in a given day, if you are trying to spend more than the normal spending limit you have, spending average you have. So for example, every day you are spending anything between $600 to $1,000, and on a particular day, if you are doing continuous transactions, say for 500 each or 1,000 each, say 3,000-4,000, then it will predict that as a fraud. So these could be some scenarios that you build into your model based on the training data. And when a live data comes in, you have to put it through that model and get the decision and act based on the decision. Okay, so you have that streaming. That could be one scenario. Or you have the network data. You see some what you call the spammers that is coming in, or hackers that are coming in. So you have to immediately put that kind of you already trained the model that say if it comes, the IP addresses are come like this, or the data packets come like this, so flag it as a hack, or safe, not safe. So based on that, immediately it will give you the action, the response before you allow the transaction to come into the network, right? So you cannot stop particularly, specifically in this scenario where some new connection is coming into the network. You cannot wait to analyze that data in a batch next 1 hour or half an hour or 1 day. You have to be processing it live, okay, so that you get the decision immediately and then act based on the decision, right? So you have one Spark batch, you have Spark streaming, both layers, and whatever you can do in a batch, you can also do in the streaming, right? So in Spark streaming, again, it is connected at the both ends, the same thing, where the data can come in from same data sources and they can put it into the multiple data sources. In future coming sessions, we will explore how we are going to, how do we use the Spark streaming with any of these data sources. We can do both using a batch and a streaming, okay? So let's see what streaming is. Spark streaming is just like a batch, a micro batch, continuously processed. It has receivers and it continuously splits the data stream into micro batches and process it, okay? So when you say micro batches, it looks like a continuous stream, but at any given point of time, it is a micro batch, a small batch of data. Even if you look at sunlight, you say it comes in packets, right? Or if you say network data, it is also sent in packets. So it's something similar. Spark streaming works on the concept of micro batches. So what it is the Spark streaming, again, it is the extension of core Spark. That is what we have been doing, that enables stream processing of live data streams. So whatever the live data that is coming in. For the best example you can see is about Twitter. Twitter is a live data feed, right? It continuously, the data keeps coming in. So you can hook up that Twitter stream to Spark streaming and continuously monitor and process the data that comes in with the Twitter. And then you can store that in any of the databases or Hadoop for further analyzing and processing it. Okay, you cannot wait for the data to come and store. There is nothing. It is continuously flowing like a river of water. So you have to collect as when the data is coming in. Once you collect, you may not want to store all the Twitter data. You may want to only store the relevant data, which is relevant to me based on the hashtags or based on your interest. And once you collect specific data, then you can perform analytics on that data. So when we come to it, we will also see, I think in the demo you have seen that how to connect to Twitter. We will explore that and also see how the Twitter data comes in into the Spark and demo that. Connecting the connectors we have from the Spark to Twitter connectors. Okay. Now data can be ingested from any of these. So Kafka, Flume, Hadoop, Amazon S3, Kinesis, Twitter, from any of these, we can put it. And then once we process, we can put it into any of the databases and Hadoop and the dashboards. So we in our sessions, we will explore Kafka and Twitter. We can have this Hadoop. Hadoop we already know, we already done, which is a file based. But we can also have a look at Flume. I mean, if Shiva has expertise with Flume, we can have a session where, I mean, he can share us his experience with working with Flume and Spark streaming. Okay. And whatever we do with the Spark, the transformations we have been using, we can use all of that on the Spark streaming as well. Map, reduce, join, and window. We will discuss what this window is. as we go into the concepts of Spark streaming. So in the Spark, whatever you read, say for example, you read data from a file. So how do you get that data in the Spark? So how do you get the file data into the Spark? In what format? What object?
Must be a file, right?
Yeah, when you read a file, how is the data coming into Spark?
Coming as an RDD if you
Or an RDD.
Yeah, so you get the data as a RDD or a data frame. Let's say RDD. Okay, so you get the data as an RDD, but because it is a batch, because you know what the data is there, the entire file has data. So you read that entire data as an RDD. In case of the streaming, the data is not constant. It continuously keeps coming in, right? So whatever you read at specific intervals. So it's polling, like in olden days, right? When you write a cron job or something, you keep polling for a transaction in the database or for a directory. So that kind of polling, you'll have a specific time. In that time, it will get all the data which is there within that time period. And that data, that batch will come into Spark as a D stream. Okay, they call it as a D stream, discretized stream. And that D stream is actually has these RDDs. Okay, so one D stream will have a set of RDDs within that. So streaming is like a batch with multiple RDDs within that batch. So in Spark batch, you get only one RDD, but in streaming, you continuously keep getting packets with multiple RDDs.
So, sorry, Harun, it's called D string, is it? D string.
Discretized stream here. Okay. So it's called a D stream. Now we put input data stream into Spark streaming. It takes batches of that input data. And then it will process those batches internally. For you, it will look like a continuous stream. Okay. Internally, it will take blocks of that data and process it individually. Now, what does a D stream look like is you will get a block of RDDs within that particular time, each time. Okay. So you define a 5-minute window. So I want to fetch data, every 5 seconds. Okay. So if you take 20 seconds, you get 4 batches, right? So in 4 batches, you will have RDDs. In each batch, you will have multiple RDDs. So RDD from 0 to 1, RDD from 1 to 2. So at each time, you will get an RDD within that. All these RDDs are within your D stream. You get that? Okay. So in 5 seconds, whatever data you are collecting will come as a D stream object, and within that D stream, you will have RDDs, a set of RDDs. Now each RDD is again same, just like your file having lines of data. When you read a file, what do you have? You have lines, right? Certain lines. So within each RDD, you have lines. So if total there are 10 lines that have come in those 5 seconds, and if you have 4 RDDs here, so each RDD might contain 2 or 3 lines of data. Okay. Now within the lines, again, you will have words, right? Yeah. So what you can do when you take this D stream, just like an RDD, we discussed that you can do map, reduce, join, all these transformations on this. So when you do all these transformations on the D stream, you will get lines, you will get words. You convert that RDD of text data from lines to words based on the map operation. And then you can count again those words. So we did in the first session, when we get into Spark, what we did, we read the file into an RDD, we split it by space or comma, to get into words, and then we reduce by key to count the number of words in the file, correct?
Correct.
So the same operations we can also do on the streaming, on the D stream, but it will work based on the time intervals, all the data that you put in that particular time interval, and then you can read the data and do processing for that data in that time interval.
So based on your time interval, you will again schedule your Spark job to read the data.
No, you don't have to schedule. That's what it is. It is a streaming job. It will keep, it will be running continuously, but it will collect the data in batch intervals. So the interval can be as short as 1 second or as 5 seconds or 10 seconds, whatever you want.
Okay.
Okay. So the data that is collected depends on your time intervals, how much you want to define. Okay. So that is the core concept of how the Spark streaming works. Okay. Now the Spark streaming can read from all of these Kafka, Twitter streams. So that data is continuously flowing in Twitter data, and then you say 5 seconds if you put interval. So every 5 seconds it will collect the data from Twitter and pull it for every 5 seconds. Whatever data is coming, it will put into the streaming, onto the Spark streaming engine to process.
Right.
Yeah, and later, so we also have the concept of data frames. So within that D stream, right? So from within this time frame, within this 5 seconds, whatever data that have come in, the RDDs, you can also convert it into a data frame and create a temporary table and do all kinds of SQL on that for particular that D stream, for a particular RDD within that D stream. See, once you pull out RDD from the D stream, it is, everything is same, just like your Spark jobs you have been writing. Okay. Now, first let us check a sample program, how to connect to Spark streaming. Then we will go further into the concepts of, windowing, sliding intervals and all that. Okay. But make sure that, there is not whole lot of functionality you write in the Spark streaming. Okay. Because the processing logic, what you write will be same, whether you write in batch job, you write in streaming job, wherever you write. Okay. The processing logic. The only thing you do in a Spark streaming is to connect and get this source data flowing in with the proper intervals. And then you extract the RDDs from that D stream and use your transformations. You're processing on those RDDs just like you do in the batch. That's all you do. So there are not whole lot of new functions, not hundreds of functions. You have all those map, join, filter, all those just like you have done on the RDDs. The same thing here. There are few functions that are additional to Spark streaming which work based on the windows. Windows in the sense, what is your window of the data? My 5-minute window or 30-minute window. So what kind of operations you want to do based on the windows of the data. So within 15, I want to do within 15 minutes of data, or do I want to do within last 30 minutes of data? Only those kind of incremental functions are there for the streaming. Okay. So let's get into the streaming space here. Where do I have? We got this working right last week. No, which one we did last week? This is Hive context. Yeah. So this is what we did last week. So we will just take this. Okay. We'll create new object. Spark stream sample. Okay, so just like you had imported the Spark libraries here, you also need Spark streaming libraries. Okay, so the dependencies we have, where's the dependencies we have here? Do we have? Yeah, so the dependency we have Spark streaming. We'll just go here and add this. I hope we are using 210. Okay, Spark streaming. Where at this? Now we will get the dependencies here, what we want. Spark conf is there, Spark streaming. Okay, Spark streaming.seconds is an object streaming context. So normally how you build a Spark context, here you build a streaming context. Okay, in the Spark streaming. So we will what we will do first here, there is a utility on the Unix here called netcat, where you can write data to a socket. So as we were discussing here, there are various inputs right here. So similar to this, just like file, it can also connect and read data from a socket, TCP sockets here. So what we will do first, we will write data to a socket, TCP socket, which is with a tool called netcat, and we will read that data from the Spark streaming. Okay. So that for that, first we will create a streaming and then use the streaming socket text reader. Okay.
Sorry, Arun, in that you mentioned you can read from a TCP socket, which I assume is from the network. But why are we writing into a socket? I don't understand.
No, we are not writing. So if it has to read from that socket, somebody has to put data on there, right, for it to read.
Yeah, so that will be then the network, right? The TCP.
Yeah, for our sample code, what we are saying, we'll use the utility called netcat.
Okay. Understood.
So that, yeah, we will give the input from our command prompt, so that the program can read from that socket whatever data we are inputting from this end. It can read from there and process it.
Right.
Okay. So we'll just write the suppressing code. We'll just put this to suppress the logging. And
what is that suppressing logic?
Suppressing is when you run the job, you get a lot of logging that is enabled. You get a lot of messages, right?
Yeah.
So I'm just suppressing that logging, so we don't see all those messages.
Okay. So reduce
So
the
that we just see the output, because our output will be lost in a lot of messages it keeps going on to the on the monitor. Okay, now first step is to create a streaming context. For that you need to create the Spark configuration and the Spark context. So first you create Spark configuration and then you create the streaming context. So you create a Spark configuration, set master, app name, we can put any app name. This is all optional. So Spark conf is not there. We need to, why it's not there? Need to import, not found. Okay. Let's import from here. Okay. So once you create a Spark configuration, previously here you created a Spark context using the configuration, Spark configuration. Here you will create a streaming context with the Spark configuration, and you also give the batch time. How much?
So why did it give you that error?
Because we did not import the Spark conf object here earlier.
Oh.
So if I don't import this,
True.
it will not know, right? So it throws that error. So
what
just
is this set master method? What does it do? Set master.
Set master is you have seen this. Here, right? So he just runs on a Spark cluster.
Okay.
So his cluster will have a master here.
Okay.
This is what it runs the Spark driver.
Right.
And it will distribute the tasks to the worker nodes, right?
Okay.
So we have to give what is your master.
Define the master. Okay.
URL. So normally you can set within the Spark job here, or you can specify when you are doing a Spark submit. When you build a jar file,
okay,
when you do a Spark submit, there you have seen, right? Last week we did -- master. We said local there. There also you can give the URL of the master, the cluster URL of the master.
Okay.
So once your job starts, right? This code here till here, whatever this runs on your driver, whatever is your driver machine where you are running the job. Once you create an RDD, that is where the master will take over and distribute it to the cluster. That RDDs, all that distributed objects. Okay. We can learn more when we do the Spark UI, how that transformations are tracked, how how we can monitor the jobs on the worker nodes, executors, all that graphical interface you can see, and also the statistics also you can see based on the Spark UI when you run the job, Spark job.
Okay.
So here we are saying local because I'm running it on my local, and this is the app name. This is optional, as I said. When you run the when you run on the UI, when you check this job on the UI, you will not see this name. You will only see this name. This is the application name by which it runs the job when you are monitoring the jobs. Okay. Even if you don't give it, it will give a default some name. Optional. This is optional. Now streaming context, you have Spark conf plus this is the your interval, where how much interval you want to read the data. Okay, so I said read it for every 5 seconds. All right, so this is your streaming context. Now, once you have your streaming context, you should always ask the job to start and await termination. So these two statements you have to put at the end. Otherwise, the job will not start. It has to start and continuously run, right? Keep monitoring. If you don't put this, the job will just scan all the code and quit. That's it. So always you have to put these two lines at the end. So there is some code where you can interfere through a handle and stop it when required, but that is all pretty later stage, advanced stage. We'll look at it later. But for now, this is a start and await termination, and then here you write whatever you want to do with the streaming context and the. So what we want to do here, let's just check whether it is able to. Okay. So what we want to do here, we want to read the data from the socket, right? So for that, first we will, there's something called socket stream. Streaming context dot socket text stream. So this is the method that will connect and read from the socket. So where you are connecting to localhost, which port? To this port. So whatever data is being published to this port, it will read localhost and port. Storage level, it's okay, it's optional. Memory and disk, whatever you want to write. So forget, it's not important right now. So just the host and port. So once you read this, what you get? Receiver input D stream. I told you, right? It's like you always get a D stream, discretized stream of the type. Type is a D string. Now within this, I told you that you will have RDDs. For each 5 seconds, you get a batch of RDDs, right? So for each 5 seconds, you get a set of RDDs, and you have to process through those RDDs. Okay. So I will just rename this here. Lines D stream. Okay. Now within this D stream, what you do, you get so I'm just doing a flat map of the data in this stream. In all the lines that you are getting within the D stream, I'm doing a flat map and split by space. Okay. So what this does, whatever data that is coming, it will split by space and flat map. So each line will be one word. Then I'm going to map. Why is not coming? So this is again D stream. Dot map. So I'm getting word here. So I will map it to word comma 1. So again, see, it is a D stream of string and integer, right? Now what we do, we will reduce by key. Okay. See, you have to see this notation, underscore plus underscore, reduce by key. This notation, this is again syntactic sugar. You can do this in Scala. This is actually same as writing your this. Take two values A, B and convert it into A plus B. This is same as writing this underscore plus underscore. So it will automatically take two values, add it. First value, second value.
So it will add the two first and second values.
Sorry?
It will add the first and second value.
Yeah. For each. So this is for each value you take and add to the second value. Okay. If you're not comfortable, you can still, go with for some time. It doesn't matter. Yeah, it looks complicated until you're comfortable, but once you're comfortable, it's pretty simple.
Yeah.
Okay. Yeah, so here also we used underscore. See, in Scala, actually, underscore has different meanings based on the context you are using it.
Right.
In different contexts, the underscore means a different thing. Okay, when you are using tuple, it is used to get the items within the tuple. First underscore 1, underscore 2, underscore 3 kind of. When you are using in a function, it can be used for partial functions, or it can be used to represent for each. So here underscore means for each line you have to do this, right? So yeah. Okay, now we have written all the transformations. We did a flat map on the D stream, we did a map on the D stream, we did a reduce by key on the D stream, just like we used to do on the RDD. So when we do this, it will internally do all of this on each line within that word stream, within each RDD, whatever RDDs it has. Okay. Now get a D stream. So we can do word D stream dot print. Okay, that's all I'm doing. What I'm doing, I'm counting whatever data is coming to that, just count here and print. So this is the program. Okay, any questions on this logic? Okay. All right, so I have done this. So next is I have to run this at this port, right? So first what we will do, we will enable the port. If I run this, see, there is no data coming in. So it's reading every 5 seconds. Okay. See, 55,000, 60,000, 65,000, 70,000. Now what we'll do here, we'll go and we have a tool, netcat, here nc-lk. I'll give this port. Okay. Now I can input the data here. It will go and hit that port, the data. Okay. So I will say hello world. See here, hello world. 2 words. The count is 1, 1. Okay. Now, if I say, see here, HA, ha, 4 times count. Yeah. Okay. Now keep doing. See here, the window is broken. I got AB 4 times and the next data came in the next batch of 5 seconds. Here, observe this. This is one window, one interval where it took the data in packets in this, and this is the another window. Okay. Got this? So see, this is a streaming application. It will continue to run until you exit manually or through program. It will keep running and looking for the data. This is the streaming. So you can change the time interval here. You can put 1 second, 10 seconds, 30 seconds, whatever you want. But most of the times, this will depend on the amount of data that is coming in. Okay, so if there is huge data that is coming in continuously, you should have shorter periods. If you have very less data, you can increase this. Otherwise, it gets clogged. If there is a lot of data coming in, but you are not reading it together, then the data might clog and your application will get slow. It will become backlog data. Okay. Any further questions on this?
Nothing.
Guys are clear?
Yeah.
Streaming application?
Yeah.
Yeah. Okay. So similar to this file, right? Similar to the socket, you get a file stream also. Okay. Just give me 1 minute. Okay, so just like socket text stream, it gives you a file stream where it can read multiple files. So if you have a directory, you can set to poll that directory. Okay, so this is our very old concept. It keeps polling for that directory stream. Whenever you move a file into the directory, when there is a new file, it will automatically pick up and read that file. So that's the file text stream. File stream you have. You can configure that as well. But apart from that, all other various data sources will have their own connectors, like Kafka, Twitter, Flume. They all have their own connectors. You can use the libraries that you have to connect to those and then pull the data. Okay, we will cover each in detail, writing programs to read the data from these data sources. From there, and you look at this transformations, right? So what are the transformations we have? Map, reduce, flat map. You can do joins, join RDDs, and just like you do with any other RDDs in the batch jobs, you can do the same job, same transformations here using the dstream. Okay. What happened? It's my file. Okay. So other transformations we will cover in the next session, but so for now we can see that these are the three transformations that we have used in streaming. Now we have the concept of windows, the data that we pull with windows and sliding intervals. We have the data we need to pull with particular intervals in time, and then do transformations on that. And you can also have state where you can retrieve from the last state. When you do a streaming, right? When you stop the streaming job, when you restart it, you can pick up from the checkpoint. When you do a checkpoint, it will store the state of the job on the directory, and when you restart, it will automatically pick up from there, and you can continue from there, from the streaming job. I have some issue with the presentation, not able to get, but we can continue this. We can discuss if you have any other topic, any question you have before, in 5 minutes, Srini will take over once we take a break. Yeah.
Any question, guys? I think Haran is doing great. I'm glad he introduced to you the streaming as well. It's only beginning, but he has shared. So it's a real time where the data flows. So one of the main reason people use big data is for streaming, because a lot of tools in the market, they don't use the big data tools thinking that they can solve a lot of problems. But as the data grows, they can still find a way to do multiple batches. But if there is a streaming, when they have to do a real-time data with high scalability and high availability is the big thing. So there are no tools which can handle. All general softwares fail. You just go and think about this problem, how people can handle the data that is flowing. So that is a very big topic, very good topic. So you get the sense of it, slowly you get used to it, and when you go to a company, they may be in the beginning stages of doing the streaming. Not all companies are fully matured in this case, in this area. So it's a good time to get into, or at least to bring to the table that you know the basics of streaming, and they appreciate you may be a good resource. So I want to see the whole thing, the batch, real time, and machine learning. All these things are so powerful tools with which you can solve a lot of problems. So I want you to appreciate that these technologies, these tools, and get inspired and rededicate yourself. With these tools, you can provide great solutions to the company. In the process, you will be learning. You'll be facing a lot of challenges, but that is okay, because you are trying to solve big problems. where there are less people to solve it. So you will be ahead of the game. So you go to any field, there is no field, there are no problems. Every field has problems. It's not only the in technology, either PeopleSoft or SAP, even the industries have problems. Retail industry has problems. Politics has problems. Movie industry has problems. You go to any field, there is no field where there are no problems. So if you don't need any, if you don't want to face any problems, the only way is you need to renounce everything and go to Himalayas, which is a big problem. So that's why stay with the group. The group is there to support you, everyone, and take everything positively. There will be challenges because you are learning machine learning means it does not mean there are no challenges. There will be challenges, but these are good challenges, good problems to solve, good problems to solve. When they're solving, a lot of people don't really bother you too much, but you'll have to break your head, you'll have to talk to your friends, you'll have to refer the documentation, you'll have to repeat the work we have to do. There's no escape for the work, but it is a good work. See it, you are solving a lot of good problems. And also appreciate the beauty. Wow, these technologies, this is flowing data. Let me use my SAP, or let me use my PeopleSoft. How I handle this? How I handle this? So I may be using integration broker here and there, but they get clogged. They get clogged if there is a lot of data. We do. Harish, we worked in Apple. You know how many times your integration broker get clogged. A lot of messages are trapped. So imagine you solving a consumer business application. You cannot solve, you cannot make your customer wait. So customer satisfaction is very important. That gives the edge to the company. So nice. Harun did a good job, I believe. Harish, how Harun is doing? Is he empowering?
Yeah, definitely, Srini. Yeah, this was, I mean, mainly the examples given where we were able to relate. Yeah, it was really good.
So do you appreciate that?
Absolutely, Srini. Yeah.
Excellent. Kishore Nand, how is your friend Harun scaled up?
It's amazing, actually. Okay, so I think Harun is doing absolutely great here.
Wonderful. Great. Wonderful. Nagesh, do you appreciate the discussions with Harun and the team? Nagesh is on mute. Leela, how does it sound? It may be challenging, it appears, but slowly things will open up. But
It was good.
do you appreciate?
Yes, I really appreciate. I was able to provide a example and explain us what he's doing. It was very good.
Oh, wonderful. Great. Hari from India.
Yeah.
How does it sound? These things, do you see certain beauty or certain interesting stuff? Though there are some lot of challenges.
Yeah. I think today's class was really good by Harun. A lot of insight we got into the database side of especially the streaming and how the data is being read and how it's stored, the buckets concept, and so it's really very good.
Great, amazing, guys, amazing. So let's focus, and we want you to scale up. So everyone can scale up. So Nagesh also did a lot of seminars, and Harun did many seminars. So as we do iteratively, we can scale up. Now Hema started showing an example in your batch. I want everyone to step up and don't stay in the mode of student. Okay, for learning, stay as a student, but start presenting, start discussing, start appreciating, share your energy, think positive, stay with the team. and appreciate the beauty. These are great, great technologies. There are no hard technologies than these. It is not just hard. Earlier also, SAP is hard sometimes, Java is hard sometimes. Those are skills, but this is altogether new paradigm. New paradigm. It means these techniques or technologies have interdisciplinary aspect. They have math, they have software, they have data, they have science, they have a lot of analytics, and it directly impact the bottom line of companies, etc. So think in that mode. Okay, how can I use these technologies to solve the big problems? So you can solve hundreds of problems, not just one type of problems. If you go to some technologies, you just always do something. You hire people, you terminate people, you provide benefits, you pay customer analytics, you collect customer data, you do a sales order, PO, a couple of problems. But these are horizontal technologies. You can solve poverty problems. You can solve government's crime prediction issues. You can solve the airline industry delays issues. You can solve a lot of image recognition issues, a lot of crime detection issues, a lot of things you can solve. Anyway, great. Good job, Harun. Keep it up. So we'll take a break. It's 10 o'clock. So 10:02. So we'll meet at 10:15. I know it's late, but I'll be engaging another 30 minutes. I want to quickly give a few things. Then we'll wrap it up. For India, it is already late. But take 13 minutes. We'll meet at 10:15.
Thanks, Srini.
Okay. Good job, Harun. Keep it up.
Thank you.
Welcome back, everyone. Hari, Harish, Kiran, Kishore, Leela, Narendra, Raja, Jairam, Siva, Leela, Nagesh. Welcome back. So I just want to introduce to you a few pointers where I want you to think about. If possible, in the weekday, play around, and come up with some questions so that we can discuss in the coming class. See, look here. You got the data, you've done the cleaning and prep. Earlier, you used to focus on RDDs. Now you are focusing more on what data frames. Then you train the model and you started testing it. So this is one area which is there is some trail end errors. The industry is going towards a lot of trail end errors. You are improving the performance. You try to change the hyperparameters tuning. But beyond it, definitely you need a better data. I think yesterday Harish asked, how can we improve this? For improving, definitely you need a good data, more training data. If there are more features, if there are more parameters that can impact. So you have a lot of parameters, but less data. It doesn't help. You have a lot of data with less features. There are a lot of factors that can influence. Those things are not taken care. That is also a problem. So it's a length and breadth issue. You have a lot of data, there's a lot of depth is there, but no features. It's not many factors, or not many columns. You have a lot of columns, but less data. That is also a problem. So definitely company will start with what they have. They cannot have a data that is not there. So that is where you need to, I want you to be flexible in your thinking. This is a statistical thinking is needed. To do a machine learning, you don't have to be a statistician because we are doing applied machine learning. You don't have to have a statistics major, but I'm pretty sure everyone studied mean, median, mode, if you just basic probability long back. It's okay, you don't remember all of that, but that's okay. But just, you can brush up. Just see one video of basic statistics, a basic probability. But of all, if you see, one thing remains the same. Statistical thinking. Statistical thinking means it's all about, they talk about averages. They don't talk about specific house value. Because what is the average value? What is the median value? What is the probability of this? Is it 60%, 65%? It may be 64%. There is no big deal, either 65% or 64%. So when you are improving this also, you need to explore all the options. Okay, how can we improve? Okay, this is the data we have. Okay, it's okay. You built a machine learning system with a 60% accuracy. That is far better than there is no prediction system. If there is no prediction system means you have 0% efficiency. There is a 50%, at least you're 50% you're guessing. Then then you start improving. You start improving means your data is you're getting more data. Your system is learning on this data. Then even you will be training them. Or you may include more features. In the first version 1, you included some features. After 3 months, you and your team realized, hey, we realized, Hari, the word realize means what? Can you enlighten our team? Realize.
So based on the data that we get on a day-to-day basis, we understand that we have to, train our model maybe once again to make our model more perfect.
That is correct. So, absolutely correct. So, you realized means even before, it is not just machine learning means, it is not just your system learning it. You are also learning. Your team is learning. Oh, okay. I think we haven't included. We might have to include more features. We have more data now. Maybe a couple of features are needed. Maybe the data is already there, but you might not have included. So yesterday also, Nagesh also asked this question. Nagesh, that is right. So it is not a textbook answer, but this is how you need to do. No, you need to go and see the situation. What is your problem? What features are needed? That comes out of the knowledge. That comes out of discussions. That comes out of the consensus. You are not the only person who take the decision. Please understand. I want to make sure you're not overwhelmed. So, Hema, I think you are working on some problems. Are you the sole person who take decisions, or at least you discuss some points with your team? Of course, if it is POC, that is different. I have a question to you. You're on mute. Okay, if you're not available, no issue. So, always you discuss with your team, or you think, you do some research. So it's based on a lot of deliberations. Nagesh, what do you think? Does that make sense? You're not on mute. Siva, does that make sense? So knowing your data is very important. You look at your data. Okay, in our class, this is okay. We just take the data, hey, 5 minutes we display, or these are the columns. We just go in a classroom mode. But when you solve it, when you do a project, it is not just everything you take decisions in 1 hour, right? Or 2 hours. So you review the data, and you will conduct meetings with your team. Then you take their opinions. If someone has already business knowledge, you talk to them. What are the data elements that are impacting their business? So all these things involve how you connect with people, how you conduct your meetings, how you ask questions, how you communicate with them, how you collaborate with them. So those collaboration skills are very, very valuable in this data science or machine learning career. So I encourage you to open up, to start thinking, and to start collaborating. Okay. So once you have optimized your features and data, which is continuously happens, that's why you build a machine learning system. Some people think, hey, my project is over. It doesn't work like that. Your system is only 60% better. Then you will be getting new data. You will be doing new trainings. You will be doing a lot of testing, continuous testing. This month testing, next month testing. not testing as a testing job. It's a part of this whole machine learning pipeline. So you train and test it. Then you work with DevOps to deploy your models. So all these things is a continuous work. So once you have optimized data, once you have optimized features, then definitely the focus is on hyperparameters. The model itself has a parameters. Like in the k-means cluster, k is the hyperparameter. In some other models, different things will be parameters. So in the decision trees also, in the decision tree, let me go here. Hope you can see. Hari, do you see this browser?
Yes.
Okay, excellent. So in the decisions tree case, so I want you this week to play with this. See, you have a decision tree. Yesterday, we have a pipeline. We have an array of steps. We pass this array of steps into the pipeline. You get a different pipeline model. You see here, pipeline model. See, I encourage you to start playing around. What I mean is, not just running this, say, you ran this is all good. You felt good. See here, how you can play around is this. Go here. I told you these steps have these things. So what if I don't put this step here, decision tree? Look here, I'm just playing. Just play around. It's okay. If it error out, you get a lot of insight. I don't want to pass the decision tree. Then let me see what happens. So let me see what happens. Your pipeline is earlier, it's a pipeline, that is all good. Okay, let me build the pipeline now. Now in this pipeline, Harish, tell me what this pipeline is taking now. It is taking string indexers, it is doing encoding, it is doing labeling, it is doing assembling. Is this pipeline has model training? No, right?
No.
Let's see, look here. I'm running this. It's okay. If it error out also, it's okay. Don't worry. Still you have a pipeline. Now see, let me use one thing. Just me say some, I don't know, some value, some, just I'm doing some testing to explore. Some variable I put, pipeline.fit strain data. I'm running pipeline data. Yeah. Look here, you got a testing explore, a pipeline model. If you see this now, if you try to bring a tree model, you won't get it because you don't have that, what you call, you didn't pass the decision tree model. Your pipeline testing explore model val, if you take this, just trying to play with this. So it cannot cast vector assembler to this. Like that you get errors. Like that you get errors. Give me 1 second, guys. Sorry for that. So start playing around. You cannot. Then even actually you can dig into it, what this might have, etc. By looking into certain methods, etc. That's okay. The next, another play I want you to do is the maximum bins. Maximum bins. Say you don't have this, you didn't set this maximum bins. Let me go here. So now let me go back. play with this. Don't keep any maximum bins or put because then you don't give, it might take some defaults. Put only some 70. So look here, I'm running it. I got a pipeline. Now I have a addition tree in it. So definitely I can have this decision tree now, decision tree model. Then I'm getting it, try to get a tree model. Okay, it didn't happen anything. Just remove that, that 70 also. Just make it actually total remove the parameters. What will happen? Like that is just to play. I'm just doing it. So different scenarios, depending on the data, you may get results. You get a lot of insight. That is what I'm saying. You remove this. So this is where actually there is one more parameter called set max depth. A decision tree will have, what happens is, this is the two parameters you see, maximum bins. Maximum bins means the number of categories. Say airlines, you have 100 airlines or 1,000 airlines. Those are the categorical bins. So by default, your tree may support some 50 bins. Then okay, it might error out saying that, hey, I have only 50 bins. You put only 50 bins, but your data has more than 300 bins. Then change that parameter. Next is maximum depth, means depth of the tree. Depth of the tree. 1, 2, 3, 4, 5. Sometimes here itself it might take, it may not be 100% pure. Maybe there is a purity of 80-20. Still it may bifurcate into branches if there is a more depth. So those parameters also helps. But at the same time, if you go on increasing the depth, it is called overfitting. You are trying to go and check even 90-10, 90% yes, 10% no. With that also you are bifurcating. Next, you got 98 and 2% impurity. That also trying to bifurcate. You go on do this, you are overfitting it. Then what happens is your results will not come correct. So these are statistical techniques. Somewhere you need to converge it. That is called optimization. What is an optimization? In optimization, you shouldn't go less, you shouldn't go up. In optimization, I think everyone knows, optimization means optimize. The optimize means not maximize. Optimize means not maximize. Leela, have you heard the word optimization? Optimize?
Yes.
So what is the difference between optimize and maximize?
Optimize is getting the best or looking for way to identify the best one.
The optimize means you have many parameters. Overall, you need an efficient system, not just maximizing one thing. Suppose you are saying optimizing your life means balancing your personal life, balancing your work, balancing your what you call your income, balancing your friends, balancing your relatives, so balancing your health. That is an optimized way of living. But some people may be extremely talented, very famous, but their health may not be good. They have challenges in personal life. They don't have time to spend. So maximizing one thing is different. Optimizing the whole is different. So that's why we need optimized systems. So that is where there is a lot of trial and error is involved. The max bins, max depth, mainly only you have two parameters actually for decision tree. So if you see, I didn't run this, I'm cutting this. With this only, when we ran the tree model, even you can see your own code. The tree model, it says the decision tree has a depth of 5 with 63 nodes. Nodes mean these are the nodes. The 5, it has a depth of 5. Depth of 5 means 1, 2, 3, 4, 5. Then you get the leaves at the end. So I encourage you to change this, use this parameter here in the max bin. You have some efficiency now with 5 is the default here in this case. So you got the efficiency, What is the efficiency you got yesterday? You got around 83%. Play with, yeah. Right.
We understood the concept of depth of 5 max depth, but what is the max bin?
Max bin, I told you, right? The number of data, number of airlines, number of categorical, number of categories in your data. Say, if you have it's airline data, right? If you have 50 airlines, even though you have 10,000 data, but it's all about the distinct airlines is 50 only, right?
Okay, yeah.
So it means there are 50 bins.
Okay, but here we are set max bins to 7,000.
No, that I put something. That's where you play around. Give no bins. Then see how the system respond. You just go and see.
Okay. So we can play around and see how.
You can play around. I put some number, 1,000. You put it. Your result doesn't affect. But when you work with workplace, you can change. You see it. It is erroring out. Let's put 1,000. Or discuss with your team. Let's use this, because sometimes the certain parameters may impact the performance of the system.
Correct. So that's what I was wondering, whether
correct.
Logically we should, if we know there are only 50 airlines, should we just limit it to say maximum like 100 and then optimize it?
No, that is a very good question. So that is where I'm saying, this is a subject involves art and science. So you discuss with them, hey, you put 1,000, it's running very good, you're getting good results. But your administrator might come say, hey, I think you are taking a lot of resources. Can you check if you need that? Can I look into your machine learning parameters? Okay, oh, you put 1,000. Does your data has 1,000? You go and show him. Yes, my data needs 1,000 bins. That's why I use 900 bins, but I'm getting an error. The program is not accepting it. Like that, you will be communicating.
Correct.
Okay, that's fair. So I'm just to keep this as a have the awareness. Okay, right. You get to know how to handle these things as you pass. That is what I'm trying to encourage you. This is also I'm showing to you. See here, depth also you understand. Depth 5. Play with depth 4 and depth 6. What will happen? See the results.
Okay. So basically, you are saying the set max those values will affect the performance. So we need to take the decision based on the actual.
Based on this efficiency, your accuracy.
Yeah.
But your focus may be on accuracy, but your administrator focus may be on the cluster performance. So there may be always some trade-off. So that is where you come with your best judgment. You discuss with team. Then take their inputs. Then you start again looking at. So somewhere you both and your team will decide. So that is what I'm interested. Does that make sense, Hari?
Yeah, sure.
Okay, excellent. So, but here now the industry is slowly going into automation, even this also. You see here, hey, you are using some logic, though it is art and science, but still to come out with, you are using this logic. You think these parameters are good based on the accuracy, and some decision tree efficiency. So industry wants you to do trial and error like this and identify hyperparameter tuning. But slowly what is happening is in the industry is going for some automation in this. In the sense, hey, can we use machine learning to do the hyperparameter tuning? Hari and Nagesh are trying to do hyperparameter tuning. And they're breaking their heads. Can we do some machine learning? Or can we come up with some abstraction, some APIs, which can help Hari and Nagesh and the team to do some hyperparameter tuning, optimized hyperparameter tuning. So that is the topic I want to just introduce to you as a placeholder so that we can even continuously work in the coming days as we discuss. So this is where this topic is advanced. So use ParamGrid for cross-validation. So they came up with a concept called parameter grid builder. It means this parameter grid builder, you can add to this grid some hyperparameters. In fact, max bins is not a really hyperparameter. It depends on the data, actually, the number of categories. But main hyperparameter for you in the decision tree is the max depth. So I'm just putting a values 4, 5, 6. It means max depth is 4, max depth is 5, max depth is 6. You can even put more. Dot build. So that builds a parameter grid. Okay. So what we are going to do is we are going to go to this grid, take 4 and find out the efficiency of the system. Take 5, find out the efficiency of the. Take 6, find out the efficiency of the system. You won't do manually. Go and do this. The program itself do that. Look here. You remember last time for k-means we wrote a function. By increasing the k by Elbow method, we found out. We are continuously changing the k. Almost in similar lines. So the Spark has come up with this concept called parameter builder. So where you pass the hyperparameter, in this case decision tree. In fact, this ParamGrid can also be used for other models like linear regression, other models also. But start understanding this. I'm just introducing to you today. In the weekday, just to think about it. Then in the coming classes, here and there will be.
I'm just trying to understand here. Now you're moving from the single classification to multi-classification. Right?
No, not yet. I'm just saying the parameter improving. That is a different topic. I am not there. This is
no. I based on the class name, I was understanding that the multi-classification. Well, is it right or wrong?
No. This is a little bit different. This is a multi-class classification. It's evaluator, only just for evaluation's sake. Don't get into that. This is just for existing problem, whatever you have done yesterday. Okay. Now the hyperparameter is array 4, 5, 6 max depth, right?
Yeah.
So those things can be whether to use 4 or whether to use 5, whether to use 6 or 7. Those can be optimized. This can be automated. That is what I'm saying. Okay. These are not classes. Okay. So this is the steps. So build the parameter grid using this. Okay. Then you're going to evaluate How you are going to evaluate? Yesterday we used that evaluator.
Correct.
Only that evaluator only we are going to use new multi-classification evaluator. Can be used for 1-0 binary classification or even multi-classification also. Where you take the label, it compares label with predictions and finally give the accuracy. That's what this evaluator do. But on what? On what? This evaluator has to work on some data.
Correct.
Has to work on some hyperparameters, right? Okay.
Right.
So that is where you have a cross validator. You have evaluator, you have a different parameters. Cross validator means do with 4, do with 5, do with 6. It's a cross validation. Then compare, cross validation. Do you get that idea? So new cross validator, okay? That cross validation needs a pipeline, which anyway, we need to do all this pipeline. Definitely you need that pipeline. Using that pipeline, use this evaluator. What is that evaluator? Comparing label and prediction. Accuracy. New cross validator is an object, cross validator object that uses a pipeline, that uses an evaluator, and that uses the param grid parameters. That uses a param grid, parameter grid, and it has another value called set number of folds. Number of folds means, hey, I use 4 or I use 5, I use 6. Say I'm using 4. Then what it is doing, all this, we are taking a training data. We are taking a training data and trying to train the data. Trying to train the data. But what if you don't have a test data? You have only one data set. Suppose you don't have a test data, only training data you have. That is the only thing that has to be divided into training and test. So I'm asking everyone, what if you divide this whole data set into training and test? When you divide 70% and 30% randomly. These are random splits. When you split one time, you got one result. When you split next time with the same 70-30, say you got a different result. There is a chance, right? Because data is changing. The first time you use 70% training data. Let me mute. Okay, I am muted. There is a background noise. Okay. So everyone, Siva, Leela, everyone please understand. You have a data, you split into 70%. You got one training set. Next time when you split, the training set may change because it's a random split. You have 100 rows. I want to have 70. The data might change, right? First time 170. Next 70, the data may be different, 70%. So which data you want to do some trial and error? First time I did this. The second time, it's like a trials. Trials. See, when you do something also, you want to validate. You do one time, you do second time, you do third time. For the same thing. What I'm saying is this number of folds means that we are using this 4. What it does is this cross validation. It takes the data. It tries to divide it into training and testing and find out the efficiency. Then again with the same parameter 4, it again splits the data into testing data and training data. Again find the the accuracy. Again, it will do 70 and 30. Again, do it and compare it. Okay, are we getting consistent results? So that is what it does. So don't get, suppose I give 5. I give 5 here. It means, hey, it takes the maximum depth 4. For maximum depth 4 itself, you do the accuracy check 5 times. How it does 5 times? You divide the data 70-30 one time and verify the accuracy. Second time again it divides into 70-30. Again it find out the accuracy. Again it divides. 5 times it does. Then it might take the average of the metrics, average of the accuracy. Harish, do you get this at least slightly?
Yes, Shani.
Can you explain to the team? Just try to at least try. Even if you don't get it, it's okay. I'll explain again. Whatever you understood.
So, based on the okay, so just a minute. I can click there.
See, if you see, let me come back a little more. See, if you go to the what you called earlier yesterday's, you got the tree, you got the tree. Let me say, you got the tree model. Then you apply the tree model on the test data. So you got the predictions. Then you try to find the what you called the comparison, comparing label and prediction. You found the efficiency. Is that correct, Harish?
Exactly, yeah.
Now suppose I didn't give you the test data. What you will do?
Okay, so
You divide it into 70-30. 70 is training and 30 is testing, right?
test, yeah.
Here I fixed it. Hey, this is training data, this is testing data. I fixed it. But suppose I give you 1 million rows. I didn't give you divide into training and testing. Don't you think you have a choice of dividing it?
Yeah, I do have.
So don't you think it's a random split, 70-30, one time you divide it, your training data and testing data you have. Next time when you divide, even though it is 70-30, don't you think those files will be different?
Yeah.
That's correct, right?
Yes, yes, Shani.
So again you did it. Don't you think it is different?
Yeah, it's different, yeah.
Are you getting it? So so you can do 3 trials. Suppose what if? So it means same data, you have a training data and testing data, you found the result. Then again you split training data and testing data. Again you found the accuracy. Again you did it. Then you take the average of it. Don't you think you get a better what you call better understanding of your accuracy?
Yes,
Right?
yeah, yes, you are right.
Because what if suddenly you split, that split was good, and suddenly you found good results, but when you split the second time, somehow you got a different training data, different testing data. Basically, your training data was different, and which was not as efficient as before. Earlier you got 80, now you got only 60, right? So that is what exactly in number of folds means here. If you see here, Param, great. muting. I see some background. We're going to close in 5 minutes, guys. So set number of folds is that. That is what exactly. So anyway, this is just to throw you some light. We'll have more discussions. So you have param grade, you have an evaluator, and you have a cross validator. Cross validator, what is this? It takes this pipeline we have built. It uses the evaluator. It uses the param grade parameters with 5 trials or 3 trials.
So, if I'm not mistaken, so for the why I've got a bit confused is because we said that set some polls as 3, and we said the number of max depth as 4, 5, 6. So, is that because you said it is 4, 5, 6, or is it because you
No,
want
there
more?
is no relation between these two. There is no relation.
So when you change to 5, then I got understanding that if we want to change the like you said now, like 30-70, or if we want to change that ratio, is what we are setting the set number for. Am I right?
No, that is fair. That is fair. But first, thanks for highlighting it, Hari. First, there is no relation between this and this.
Yeah. I got a bit confused because of that. Because there also is 3 and here is 3. So
exactly. That's why I asked Harish. That's why I asked Harish, hey, can you explain to the team? Because mind thinks it connects in a randomly. That's why the discussion helps. So I want to have a clarity that this has nothing to do with it. Okay. This may be tomorrow. This may be some linear LR model where there is no issue of depth or something, some other parameter could be. Right. This is just a common sense trials, actually. This is some sort of clinical trials. People say, right, in medical, clinical trials.
But so, for that, we can set the like 30-70 or 60-40, we can set those values separately.
No, 60-40 also, it is not dividing. But when you divide also, that is a random split, right? When you split first time, you got a very good data. The output is very good. It is simply saying that clinical trials. You test your thing on one thing. Same medicine is acting differently on different people. So same depth. For the same depth, I may get a different results if in multiple cases. So you put a depth 5, depth 4, it is good. I got 90%.
No, what I'm trying to understand is for the same depth, how will I get different values based on the set num code? That's what I'm trying to understand.
Why? Because same depth, the set num fold.
If I do 5 times, how will I get different values?
That is what I'm saying. You see here, you forget about the set num fold. Let's use our common sense. Your depth is fixed. So this is what I'm saying. I gave you data, 1 million. You took 70-30%. First time when you took 70%, you got one training set.
Right.
Second time when you took 70%, you got a different training set.
Oh, different training set. Okay.
Exactly. That's a random split, right? Same data, 1 million. But since you put 70% of 1 million, you got 700K. First time that 700K rows are, second time 700K rows are different, right?
Okay, got it. Okay.
So then in the first time you got 83%. The second set you got 75% accuracy.
Yes.
Your model. Of course, you'll use the training data to evaluate it definitely.
Yeah.
So got it?
Yeah. Okay.
Very good question, guys. That would help not only you and everyone. Okay. So basically, when I run this, you get a param grade. Param grade is an array, and evaluator is a evaluator object. Cross validation. You will have cross validation. Okay. Then the cross validation. This cross val is a validator. You apply that cross validator onto your training set. Here, see, if you see here, we haven't talked anything about data here. Harish, everyone, please see. I didn't talk anything about data here. This is where I apply fit. The output I got cross-val use pipeline, cross-val use evaluator, cross-val use params, and number of folds. I apply that on the data. I get a CV model, cross-validator model. I'm running it. Cross-validator model. So it runs a little bit more time. We'll finish in 5 minutes, guys. Thanks for staying to here. So now it is taking more time because it runs for 4, it runs for 5, it runs for 6, and for each depth I put 5. It does 5 folds. It times 5 times for each depth. Okay. Then you got a cross-validator model, which is a tuning cross-validator model. Then that you get the tree model. The cross-validator model has a method called best model. The best model means out of all the things it does, the trials, clinical trials, etc. You get the best model. That instance, last instance of decision model, you get the CV model. Let me run this. So when I ran this, it took the depth of 6 with 121 nodes. Depth of 6. So let me display the tree. I got a 6. I got another layer. You see 1, 2, 3, 4, 5, 6. When we did it, by default, we didn't put anything. This is what this was not there in your yesterday C or code. By default, it took 5. Depth of 5, you got this tree. But now when I used cross-validator, I got depth of 6.
Right here.
So it checked the overall efficiency of the whole system. It thought, hey, better efficiency, both accuracy and system resources, is automation. So it did the optimized overall. It thinks that 6 is the good depth you should use. Then okay, then finally you can find its accuracy. Sometimes the accuracy may be slightly different, slightly even less than what you have. Earlier, look here. Now you got only 80%. Earlier we got 83%. So this is where try to understand this optimization doesn't use just accuracy alone. Accuracy plus system resources, some other system programming is also done. They put on this particular APIs. Anyway, just I want to keep this as a topic for you to open up. So okay. So cross-validation, param grid is one of the technique you can use. Let me show you here before I take up the questions. Look here. This is the documentation. Please focus on this. This is the old way of doing machine learning. This is more efficient way of doing it. In this way of doing, you will always see the ML as the word. Here you will see ML lib. So don't get confused. So here model selection and tuning. So how the way it is, yesterday we have seen the features. This is model selection and tuning. There are a lot of things. Cross-validation, and different way it uses param grid, etc. Different examples are there, but I'm just trying to open up this topic so that in the coming classes we'll be including this also in our discussions. Okay, now tell me any question.
Today we have two methods, right? One is cross-validator and another one is auto-val something. Yesterday.
I can't hear you, Narayana. You might have to use earplugs next time. There's a lot of background noise.
Okay.
Yeah. Okay, I'm putting you on mute. Then, okay. So next week, we are going to have a good discussion on what you called the multi-classification, where I'll show the data. I don't have right now time, where you can have the 50, it is, I think it's a small font. So okay, see 5041, etc. This is actually a images data. Images data can be converted into text using pixels. We don't have time right now, but I will work with I'll work with Hema team and make sure a good demo is going to happen either on Saturday or Sunday. Okay, please focus your discussions on these topics. Any other question? Last 1 minute. Yeah, Siva, Lila, Siva.
Can you go back to that ML what you were showing us for the Spark?
What is ML? You want me to show this?
So there you said one is MLlib and one is
MLlib is a RDD based, though it's a MLlib main guide. MLlib is RDD based. If I show some example, see here, you'll
so we
see
should
like
refer this mainly.
so MLlib classification models. Okay.
Okay.
So if you take say classification and regression, you see here classification and regression. See classification and regression here.
Yeah.
So this is also classification and regression. You have linear models, decision tree models. Take decision tree model. Decision tree model. Let me show you some example. See here they use MLlib tree decision, MLlib tree model.
But we have used in our coding we have used ML.
Yeah, so this is we did use for k-means if you go and see. So this is a little bit lower level of coding. So next 2-3 years, they are going to discontinue this. They are going in this way. Now everyone is using this. You go here.
ML.
Yeah, exactly, ML. Classification and regression, same thing I'm going here. It's a good question. You have a classification model, a decision tree classifier. See here, decision tree.
Yeah,
see
ML, yeah.
ML classification. Because this uses more data frames and it has more methods. They don't here they don't have lot of things. It's not a, of course at that time this was their last 5-6 years. Okay,
correct.
This is the last one, and it's like a always new cars will be coming. Now if you see Ambassador, it looks like a it doesn't look like a good car, right? But in olden days we don't have any other option than Ambassador. Everyone loves Ambassador. Okay.
Okay.
Okay, excellent, good questions, guys. Sairam, does it sound good? Kiran, you feel comfortable with this?
Yes, Srini.
Yeah, of course, a lot of things sound overwhelming, especially
Yes.
last note. I'm introducing you. I just introduce you to. I'm opening up the door. In the iteration learning, first you open up, just see it. Oh, okay, there is a concept called we can do certain automation here. Just keep it as a placeholder. Then next class when we discuss, you get more depth. Next, Hema, when you give some demo, you get more depth. That's how you gain hold on to these subjects. Kiran, does it make sense?
Yes, Srini, perfectly.
Okay, awesome. Last, Sairam, Harish, how does it sound? Okay, excellent, guys. I think we are good. Thanks for staying. More time. We'll catch up next week. Good job, guys.
Thank you, Srini.
Thanks, Srini.
You were saying, Arun.
Cool, guys. Have a good day. Done. Bye.